Do you feel the vibes?
Okay, so all right, so let's talk about inverses. An inverse relation is basically one where for every coordinate AB, there is another BA, right? So if you take a look here, the blue parabola and the green are inverses of each other. And as you can see, the blue and the green are reflections of each other, but around this red line, y equals x. Okay? So in the relation, notice we're not calling it a function. In the relation y equals x squared minus 4, now that's a parabola. You have the point -3, 5. In its relation, there is a point 5, -3, right? And, you know, in the same way for all the other points, right? So you have -2, 0, 0, -2, and so on and so forth. Okay, now, if the inverse relation is also a function, then it is called an inverse function, and we call it f inverse like this. And obviously, as you can see above, not all functions have inverse functions. Like this one here, the blue is a function, but its inverse is not. And you all were just saying we can figure that out using the horizontal line test. Like this one here, this function passes the horizontal line test. So its inverse would also be a function. Okay, so we say this blue has an inverse function. That's how we say it. Okay. So with these, we don't have to spend time doing it, but basically all you would have to do is, you know, like graph them and then look at the graph and just inspect the graph, and that's enough to see whether or not it has an inverse function. There's like, it's not really above anybody's like capabilities in this room, right? Okay. So that first one actually does not have an inverse function, because I think it's like a W, huh? Oh, it's just a parabola. Yeah. Oh yeah, it's an even function, of course. Yeah, this one's an even function, so it does not have an inverse function, but this one does. All right. If a function passes the horizontal line test, then we say it's 1-to-1. That literally means for each x there is one y, and for each y there is one x. Okay? All right. Okay, so we all know how to find an inverse function, right? Remember, first you interchange x with y, and then you solve for y. Okay. So, and remember we also did inverses with trig functions recently. So you all know, right? When we're doing like a function and its inverse, the domain and range will swap. So it's all like fresh in your memory. Okay, so let's take a look at this. This one actually does have an inverse. So let's go ahead and find its inverse. So first let's write this as y equals x over 2x minus 1. We're going to swap x's and y's. I'm going to cross multiply. And then let's distribute. Bring the y over, x to the other side, take out the y. So then y equals x over 2x minus 1. So I rewrite this as f inverse of x is equal to x over 2x minus 1. Huh? Okay. Okay, so hang on, Evan. So yes, that's what we started with. So it actually is its own inverse. Because it's just the same graph because it's the way the symmetry works out. If you reflect it around the line y equals x, you actually just get the same thing back. I know, it's super cool. But we also have to say x cannot equal 1/2, right? Okay, Evan, what were you saying?
I don't understand how you're supposed to swap the x and y back.
Wait, in this step?
After you had 2xy minus x equals y.
Yeah, so I took the x over there and the y over here.
Oh, that's good.
Okay, this one. So this one, y equals 2 root x minus 1. So swap. And then x squared is equal to 4 times y minus 1. I'm actually going to divide by 4. And then x squared over 4 plus 1 is equal to y. So y is 1 over 4 x squared plus 1. So I'm going to say f inverse of x is 1 over 4 x squared plus 1. Okay, but now there is a mismatch here, right? Because if you graph f of x, it's 2 times root x minus 1, right? That's f of x. Okay? If you graph f inverse of x as we have right now, it's a full parabola right here. Right? But that can't be. That means I need to restrict the domain so that I only take the right half of it. Does that make sense? So I need to say the domain is from 0 to infinity only, so I can get rid of that 1/2.
The domain in f inverse of x can only be where f of x exists?
Yeah, because...
And should it start at 1? Because f of x is transformed.
No. Because, okay, so for this, the domain is 1 to infinity. The range is 0 to infinity. Correct?
Yeah.
Okay, but when you find the inverse, right? The domain and range will switch. So the domain will become the range of this. No, the other way. The domain of, yeah, no, I was right. And the range of this will become the domain. Okay? Yeah. Of f inverse of x. Okay? All right. So here, this is m of x, x squared, but only from 0 to infinity. So here it's already restricted domain. Yeah, x, this is in the set of, x is the set of 0 to infinity. Okay, so this is m of x only. It's a restricted domain. So now that passes the horizontal line test, so we are allowed to find the inverse of it. So y equals x squared, x equals y squared, take a square root. Okay, so now y equals plus or minus root x. However, because it's only the positive side here, we just take the positive side. So y equals positive root x only. So f, I know, y was right. F inverse of x is equal to root x. So had it said x is the, x is the set of, let's say, negative infinity to 0, then we would have taken negative root x, right? Because it would have been the other side. Isn't that cool? Isn't math like so awesome? Right? Talk about stress relief. Okay, now, I always forget to change this. Okay, so composition of inverse functions. So the theorem says, if two functions are inverses of each other, then f of g of x is equal to x, g of f of x is equal to x. And the thing I always forget to change, even though I look and look and look and look, is this shouldn't say show algebraically. This should say verify. And when it says verify, you have to, by law, use the theorem. Okay? By mathematical law. That I just highlighted. Okay? So, you have to verify that f and g are inverses of each other. So, remember how for the symmetry I said separate your workspace into 3? Now I'm telling you separate your workspace into 2. So guess what I'm going to be looking for when I'm grading this question? Okay. Okay, so in the first part, you have to find f of g of x. So let's do that. This is the square root of x squared minus 10x plus 33 minus 8 plus 5. And when it says verify, like, don't lose hope, okay? Remember, the math is bigger than you. So, like, trust in the math and, like, power through. Okay, so this is x squared minus 10x plus 25 plus 5. This is, wouldn't you know it, x minus 5 squared plus 5. Oh my God, that's x minus 5 plus 5. X! Oh boy! Oh my God. Okay, now let's do the other one. Remember, gotta have both. It's and, not or. Okay, g of f of x. Okay, so now, no.
If it says verify and it has the greater than 5,
Yep. Okay, so here we go. You ready? Okay, f of g of x. Okay, so here's f. X minus 8 plus 5 squared minus 10x. Oh boy, this is so much fun. Okay, plus 33. Okay, let's do this. Oh my God, we got to square this now. Okay, square the first, x minus 8 plus 10 root x minus 8 plus 25 minus 10 root x minus 8 minus 50 plus 33. Okay, let's see. Some things should cancel here. Okay, and they do. Look, 10 root x minus 8 minus 10 root x minus 8. Okay, so now we have x minus 8 plus 25 minus 50 plus 33 is equal to, oh my God, it's x. Look at that. Wow. You see that? Look at that. That is so cool. That is like literally so cool. Wow. That was beautiful. You can't lie. You can't lie. Right? So cool. Okay.
Wait, is the second one where you cross arrows at 10 times add x minus 8 and add x plus 8?
No.
Oh, because you're adding it's divided by
Okay. Now, use the graph of each function to graph its inverse. Okay. So what you got to do is, oh my gosh, Evan. Okay. So we have to pick points, and then you have to take their corresponding like inverse points. So, like this one is a good point, -3, 0. And then like pick like, integer points like -2, -1. What else is a good point? This one, 1, -2. And then maybe this one, 6, -3. And so for each of them, you got to do, swap x and y, right? So 0, -3. -1, -2. -2, 1. -3, 6. Right? Here we go. Okay? And so look, if you now draw the line y equals x, okay? If you draw the line y equals x, and if you take the corresponding points, they are reflections of each other around that line. So look at this point. These two are reflections of each other, right? Like, do you see that? These are each like reflections of each other around that line. Okay? Isn't that cool? Okay? All right, let's take a look at this one. So sometimes you do have integer points like that, and sometimes you just don't, right? Because if you have like e's and ln's, like you don't have integers like that, right? Like e to the nothing is an integer value. So you're not going to get such easy points to graph. However, you do have intercepts. Like for example, look at this one. You have 1, 0. But look at what you can do. 1, 0 will graph to 0, 1. Okay, but remember, okay, when you go between inverses, right, everything associated with the x switches to everything associated with the y, and vice versa. That has to do with domain and range. That also has to do with asymptotes and everything else. So these have asymptotes. So it looks like there is a vertical asymptote of x equals 0. This will become a horizontal asymptote of y equals 0, right? And it looks like this is in the negative, so that will be in the negatives, okay? And it looks like this is like, leveling off at about 2 for the y's, 6 for the x's. So it'll be 2 for the x's, 6 for the y's. Do you see what I'm talking about? Or the other way around? Wait, what did I say?
I did it.
Oh, it's level off at
2 for x.
What is RA?
Yeah, so here. So it'll look like this. Right? That will be the inverse. And then if you can see around the line y equals x, that's definitely symmetric. I mean, it kind of is kind of perfect. You know,
No, like,
good
not
enough.
like it doesn't.
Yeah, it's good enough. All right.
Are we supposed to know how to graph LNs?
Chapter 3, yeah.
Or last year?
Last year we never did. Huh?
We did LN.
We didn't graph because we don't graph.
You mentioned graphing, and I was like, oh, wait, did I forget things from last year? And I was like, oh.
It's like literally the best timing because we just finished.
Or we look at my graph.
I do mean it, seriously. Okay, just ignore me.
I'm ignoring. We're done though.
Oh, okay. Fine. It's hard.
It's so hot in here. Okay. Since we so were there any other questions on the homework?
Press start.